Okay. So we were discussing second lesson, and we were discussing about the history of computing. So basically, what is the historical usage, historical way of evolution, like how the computer evolved. We discuss about that, and so then we discuss about different generations of computer: the first generation, second generation, third, fourth, and the future generation, which is actually fifth generation. Currently, we are in fourth and fifth generation. It's a mix of that. Right? Fifth generation is started, but we are still not declaring that fourth has ended. Fourth is still there, but so some people think fourth is over now and we are in fifth. Some are arguing no, we are in fourth and fifth both. Right? Anyway, so that's why here it's mentioned as future generation. But anyway, we have 5G for the fifth generation, which is using artificial intelligence, AI. And then last day I explained about different classifications: technology based, analog and digital. What are they? What are the analog computers? What are the digital computers? How we categorize? And what are the special purpose, general purpose computers? And what are the different kind of machines based on the size and performance? We discussed that as well. Right, today, yes, today we have to discuss about, I think this part is also, yes, we have to discuss about more about these devices, major hardware components, and also the one Neumann architecture. Actually, we have already discussed that in the first lesson. When we are discussing the first lesson, we discuss about what is one Neumann architecture, and then about these memories, memory and memory hierarchy. We need to analyze that as well. Right. So let's begin from that level. Okay, so let's begin from there. And the first thing is major hardware components. Hardware means tangible components of the computer system. Hardware means tangible components of the computer system. We call them hardware, right? So here, actually, this explains how these devices are connected, right? How these devices are connected is explained here in this block diagram. This is what we are going to learn as one Neumann diagram or block diagram. How the computer devices are connected, how hardware devices are connected. So there are 6 categories basically in computer hardware system. There are 6 categories: input, output, memory, processing, storage, and one is missing here, that is communication. So those are the 6 categories that we can see under this computer hardware, right? Okay, let's write down that as well. Hardware subsystem. What are the categories? First one is input devices. We can say these are physical or tangible components of the computer system are called hardware, physical or tangible components. So under that you have input devices. So can you give me a few examples? This is very basic, right? It's like fundamentals. So what are the input devices?
Keyboard.
Yeah, basic input, primary input is keyboard. Then you have mouse or mice. Yes. What else?
Trackball.
Yeah, so these are actually category of pointing devices. Trackball, tracker ball, or trackball, touchpad, and light pen, joystick are categorized as pointing devices. These are pointing devices. Why? Because you can move here and there in the screen. Therefore, those are called pointing devices. Yes. What else?
Barcode reader.
Yes, then you have scanners. Scanners are actually two categories. One is handheld, and the second one is flatbed, to keep in the surface. And also scanners can be general or special purpose, right? Handheld means you keep in the hand, flatbed means you are keep in a desk, and you can categorize the scanners into general or special purpose. Handheld, these are self-explanatory, right? Keep in the desk, or keep at a solid location, fixed location. Right, general purpose, special purpose. Anyway, so can you give me examples? So you can say a document scanner, barcode scan, QR code, 2D barcode thing, QR code scan. So I'm always giving the summary, right? So I don't know. So if you need explaining, like more explained one, tell me, then I can send like that. But whatever the points you need for the examination will be given. Document scanner, barcode scanner, QR code scanner. Anything else?
Magnetic strip reader.
Magnetic MSR, magnetic stripe reader. Why? For reading, this is for reading this ATM cards, credit cards, debit cards. So MSR or magnetic stripe reader is there. And there is something called OCR, that is for optical character reader or recognition. Right. I think, have you used Google Lens? Google Lens in mobile phone?
Yes.
All right. That has OCR feature. That has OCR feature from a document or printed note or maybe handwritten document or from a book. You can read the text and you can even translate it real time after reading. So reading and translation, two things are there. So that is OCR feature. And for O-level and A-level MCQ paper marking, so there is something called
OMR.
optical mark reader. That is for marking papers. Optical mark reader, basically used for marking papers. And there is another thing, magnetic ink character reader for check reading. Magnetic ink character reader, that is for check reading and all. So then not only that, you have MRI, magnetic resource imaging, MRI scanners. You have PCR scanners. These are medical purpose scanners. Those are also scanners, but these are actually special purpose, right? It's not like document scan. These are also special purpose. But MRI scanner, PCR scanner, CAT scanner, PET scanner, these scanners are used for diagnosing. CAT, PET scanner, ultrasound scanner, X-ray. So these are used for diagnosing purpose. Those are also scanners, but not directly related to the computing domain, but still using computing components. So those are also scanners. Okay, so then another one is microphone. Microphone is also input device. So keyboard, mouse, scanners, microphone. Anything else? Sensors and loggers. Sensors are also taken as input devices. Sensors. So the sensors actually, these are sensing the environment, ultrasonic sensor, infrared sensor. These sensor modules are also used as input devices, but they are sensing, they are automatically getting input from the environment. Automatically getting inputs from the environment. Those are called sensors. Right, those are examples for input devices, and the second category is output devices. So under that, you can say the main output is screen, or sometimes called VDU, visual display unit, or sometimes it's called monitor. Anything can be taken. Projector. You have few types like overhead projector. Overhead projector is like its old projector which was used for displaying slides and writing. Slides pen. So for writing and slides. So if you want image, this is overhead projector. So that is a simple projector with a lens. You can even create your DIY own version of overhead projector. And it's like this, and you used to write down. Here you can see a person, he used to write down in this projector and it will be displayed here. And instead of writing, it is possible to display slides, this transparent slides. Light will go through this and this lens will magnify it. And you can see a preview in the screen. So this is called overhead projector. Right, but now actually this is not that much popular because this was all technology. What is done actually, the image is taken, light source is taken, and it will be magnified and sent back to the wall. So that is the duty of overhead projector. But when it comes to the digital projector, the other one, right, overhead projector, and you have digital light processing, DLP projector. Or you can say these things are multimedia projectors. That means you can directly connect to the computer and display some image. This DLP, LCD, LED versions of projectors are there. That can also be taken as output device. So if you need like I had the note for hardware. Oh, this is not the one, sorry. This is not the one. Yeah, this is not the one. So it has more information. I'll send my hardware on this separate one. But so this is for your examination. For your examination, you need to know about these inputs, outputs, etc. And the monitor also, there are categories. So what are the categories of monitor? Yes, old monitor was
CRT.
Yes, old monitor was called CRT, right? CRT, cathode ray tube. Cathode ray tube. That is CRT projector. So that was like a large box, and it's using CRT. It's using electron beam, electron beam. Actually, here you can see this large image. So it's sending the electron beam. This beam is bended. Beam is bended and projected to the POSPER layer of the screen. This POSPER layer will illuminate. It will look bright. The earlier days, it was only 2 colors, but later there were like 3 colors, RGB. So this POSPER layer will be illuminated according to the light beam given. Actually, this is a single beam, but the single beam is going Z way. Single beam is projected in, it's like Z, like this. A beam but it's projected like Z. So let me show. So let's think this is your screen, and the beam goes like this. This electron beam, it goes like this. Let's draw another color. Here from left to right, again the next line left to right, next line left to right, next line left to right, left to right. Likewise, the electron beam will move through the phosphor stream. So this is what happened. That is why when you point a camera, it will show some flickering. When you look at your TV or monitor using a camera, sometimes you can identify a small flickering due to this. When you take a photograph also earlier, you could see the flickering, but nowadays you cannot see the CRT monitors. That's a problem. So this single beam is moved like that, and this will happen 60 times or 50 times. So this will happen 50 times or 60 times per second. So we call 50 hertz. More the frequency, more the brightness. Increase the frequency, increase the brightness. So what is the advantage of this structure? Why a single beam is used? Why there are no multiple beams? And the next thing is why it is happening for 50 times, 60 times. Why that much of times it's happening? So any idea why this is happening and what's the reason behind that? Yes? Any idea about that? You can comment, you can give your own opinion. So I'm not asking, I know that sometimes you might miss the lesson, you have not learned that. I'm not asking the exact thing, but what do you think? Why there is a flickering? So why there is a rotation? Why there is a this Z-like beam, and why it is happening 60 times, 50 times per second? So what's the reason? Yes. Hello, can you hear me?
Yes, sir.
Okay. So if you don't know the reason, if you cannot think, so the reason is, so in human eye, so whatever going through the lens, eye lens, will be moved to this optical nerve system, right, which is in the wall of the internal wall of the eye. There, the preview remains some time without deleting. So if you have learned science, I think you know the thing. Akshikajya haraha yaneva gihila drushti vitaneta vadino. Etan tiyana drushtika snayu, optical nerves. So these nerves will move that to the brain for the understanding. Anyway, this illuminate, this preview remains for some time, right, without deleting. That's why when you look at light, direct light source or maybe sunlight, and when you close your eyes, still you can see the sunlight inside your eye. The torch එකක් දිහා බලලා එකපාරටම ඇස් පියාගත්තම when you look at a torch or when you look at a light source and close your eyes, you can feel the preview for some time because it remains in your eye. So that is why. So if you are using multiple beams, then it will consume more space, more power. Ultimately, your monitor will look like a cinema theater. So it will look very large because multiple, each pixel will get a beam. Make a choti pixel like screen එකේ තියෙන. So if each pixel මේ pixel සාමාන්‍යයෙන් 1000ක් විතර තියෙනවා screen එකේ. 1024ක් සාමාන්‍ය. සමහර ඒවා ඊට වැඩි අඩු වෙන්න පුළුවන්, වැඩි වෙන්නත් පුළුවන්. මගේ එකේ තියෙනවා ඒ වගේ. So let me show you. So you can see this as a resolution, right? String resolution can you make it? So let's go about this Mac, and you can see in my screen, you can see 1440 into 900. මේ පැත්තට 1440ක්, මේ පැත්තට 900. All together this is 1440 into 900 pixels in the screen. එතකොට මෙතන it's closer to, let's say 1000 into 1000. 1000 into 1000 is 1 million. 1 million pixels. If you use 1 million beams, think about the size of monitor. And if you power all 1 million beams, the beam but if you in the earlier stage, මේ ඔක්කොටම power දෙනවා කියමු, මේ million 10ටම power එක දෙනවා. million 10ටම වෙන වෙනම beams තියෙනවා. So identically your monitor will be super bright. Right? Your monitor will be super bright, but the thing is, so it will be consuming super voltage too. It will be consuming a lot of power. And not just that, not even the power, it will consume a lot of space. That is why you are not using multiple beams. Okay, why it is moving 50 hertz? Why it is like here to here one time? ඒ වගේ මෙතන මෙතන එක පාරයි. ඒ වගේ පාරවල් 50ක් තප්පරයට. That's why 50 hertz. ඒක 60ක් වෙන්න පුළුවන්. 120ක් වෙන්න පුළුවන්. When you buy a TV, you can see this. So if you go and check your TV, you can see this in your TV also. What is the hertz? TV එකේ ගහලා තියෙන hertz කීයද කියලා. 60ද 120ද, right? So more the frequency, more the brightness. එතකොට මේක අර ඇහි හැදිලා මැකෙන්න කලින් තව රවුන්ඩ් එකක් යනවා. ඒක හැදිලා මැකෙන්න කලින් දැන් මේ පික්සල් එක පත්තු වෙලා නිවෙන්න කලින් තව පික්සල් එකක් හැදෙනවා. ඒක පත්තු වෙලා නිවෙන්න කලින් තව එකක්. ඔය විදිහට පික්සල්ස් ඔක්කොම පික්සල්ස් මිලියන එක. All 1 million pixels will be eliminated within a fraction of a second. So you cannot see that as an individual pixel. You will see all pixels are eliminated because of the speed. Because of the speed, you can feel all pixels are eliminated. Why this is happening? This is actually 1 million pixels will be eliminated and gone within 1 divided by 50 seconds, a fraction of a second. You can't see that. You will think all the pixels are bright and all the pixels are active. You will see like that. You will feel like that. And not only that, that will also happen 50 times. Then, actually, you can change the preview. Ne? So let's say you are playing a video. The first time, the next millisecond, another one. Next millisecond, another one. These are called frames. When you are playing a video, so you can see smooth movement, very smooth movement, and also very good illumination in the screen, because each time within a fraction of a second the pixel change, but you can't see that. We will think it's a continuous video. Understood the point? Understood the technical side of that?
Yes, sir.
Okay. But anyway, so remember that this will not be asked into that depth, but still you need to know the theory, how it works. I'm not going to give notes on this because I'm going to give a note on this. Today's lesson is all about CRT monitor and how it illuminates. I need to summarize this for you, right? But you need to remember what is happening there. So you can see different hertz, like let's say 40 hertz. I'm not sure 40 hertz are there, 60 hertz, 50 hertz, 60 hertz, 120 hertz. These are strings. For TV, you can say. In TV also. Now also this is happening, but not in the CRT way. There are some other ways. Like, can you see the comparison? Okay, you can see this. This is one example showing this movement. Let's see that. Try to understand. Okay, you can see these monitors. Monitors are having this hertz, right? So the difference is when the frequency is high. And you can see the frequency is high. Here you can see. So let me play this. The blurry, like what you can see, crystalness will be really high. You can see this is fast movement of a vehicle. It is slow down. So which looks better? Which looks more smoother? Hello?
Yes, sir.
Which looks more smooth?
60 hertz.
60. Smooth. I'm asking smooth. No. අර කැඩි කැඩි පේන එක නෙමෙයි මම ගන්න ස්මූත් එකක් වෙන්නේ කොහොමද? ගොඩාක් ස්මූත් යන විදිය බලන්න පේනවද කියලා.
220 hertz.
It's 240. When higher the frequency, higher the quality, right? Higher the frequency, it's higher the quality. So that is why the high frequency rates are important. If you are watching if you are watching high frequency, like if you are watching fast moving videos, so better if your monitor has high frequency, then the quality will be high. So these are the points we'll be asking the examination. So which monitor has high quality? So you'll be given few answers. Which one? One with 30 refresh rate, the second one 60 refresh, the third one like 60 refresh, the fourth one 120 refresh rate. So you will know that because you know practically this is the scenario behind the monitor. So that is why. So you can't write everything as a note, but you need to understand that. මේ ඔක්කොම නෝට් ලියන්න ගියොත් නම් ඔයාලට මේ මම හිතන්නේ A level කරන්න වෙයි කියලා නෝට් කරව ගන්න වෙන්නේ. හැබැයි මේක ඔළුවට නම් දා ගන්න වෙනවා. රිෆ්‍රෙෂ් රේට් එක කියන්නේ මොකද්ද? වේගෙන් පික්සල්ස් පාට වෙලා නැති වෙලා යනවා. එතකොට ඒක වේගෙ වැඩි වෙන්න අපිට වේගෙන් යන දෙයක්. හරි වේගෙන් යන දෙයක් හරි ක්වොලිටි එකට පේනවා. දැන් වෙපන් එකකින් වෙඩි තියනවා කියමු. අර නේ උණ්ඩේ යනවත් පේනවා මෙහෙම. එක තැනක නවත්තලා අපිට බලන්න පුළුවන් when the refresh rates are really high. Otherwise, you can see slow motion videos, but not when it is in the fast motion. You will not be able to see. You will see a blurred video. car එකක් යනකොට නිකන් බොඳ වෙලා ගියා වගේ තමයි පේන්නේ. අර හැම smoothlyම පේන්නේ නැහැ. So higher the refresh rate, higher the quality, right? Higher the refresh rate, higher the quality. Okay, different refresh rates. You can see here another one. Right, so this is the brightness of the screen. You can see the quality. Can you see the first one is blurry? මේ පළවෙනි image එක මේක මේ අර වේගෙන් යන කාර් එක ෆොටෝ එකක් අරගෙන තියෙන්නේ ඒ මොනිටර් එකෙන්. ඒක පොඩක් blur වෙලා. දෙවෙනි එකේ you can see it has a still image, right? Can you see?
Yes, sir.
Can you see the difference? So that is the thing. So more the refresh rate. So now you know what is refresh rate. Refresh rate is why refresh rate is maintained. You know reason for that as well. A refresh rate are maintained karane because you can't color every pixel. You can't give electronic beam to every pixels. That will be using heavy current as well as that will be using more space. Therefore, you are using a refreshing way. Refreshing way එකක් තමයි screen එකේ. කියන්නේ මේ screen pixels ටික එක වෙලාවෙ ඔක්කොම පත්තු වෙන්නේ. ඒ වෙනුවට මොකද කරන්නේ? එක pixel එකයි පත්තු කරන්නේ. ඒක යනවා cycle එකක් වගේ. එක pixel එකක් පත්තු කරනවා left to right යනවා. ඒ ටික ආයෙ මුලින්ම පටන් ගන්නවා ආයෙ left to right යනවා. ආයෙ මුලින්ම පටන් ගන්නවා ආයෙ left to right යනවා. Likewise, you will do 50 times, 60 times, 120 times per second cycles. So this is how you maintain the quality of the screen. Okay, back to the work, back to the lesson. So here now you have learned about these input devices, and also we learn about the output devices. Input devices, actually we don't want to learn much about that. You just need to know the basics, what is happening there. Actually digital camera, even though they have given this, so I don't like this answer because digital camera is a different system. According to the syllabus, yes, correct answer. Practically it's wrong. Why? Digital camera has a monitor. Digital camera has a memory. Digital camera has a processor. How it become input then? ඒකට memory එකකුත් තියෙනවා, processor එකකුත් තියෙනවා, display එකකුත් තියෙනවා. ඒකට input device එකක් කරන්නේ වෙන්නේ. It has all these components. But they have taken digital camera as input device, but I am not agreeing with that. But according to the syllabus, yes. Because it's given. According to the syllabus, yes. And video camera is also given. Digital camera, video camera. But web camera, correct answer. Why? Web camera cannot be used without a computer, no? Web camera eකට වෙනම input output නැහැ. So you can't use that cannot use that without no computer. So web camera, I agree, but but video camera, digital camera are still there. So you can write that as answer for the paper if it is there, but it's not very good answer. Remote control, right? So these are also input devices which I couldn't mention there. So I'll add that. Sensors, remote control, webcam. web cameras. So those are also input devices. And output devices, CRT, LCD, liquid crystal display. Liquid crystal display. Liquid crystal display. LED, light emitting diode. Light emitting diode, that is also a type of. And you have TFT, thin film transistors. And plasma. Thin film transistors, plasma, which is using a gas. So here a liquid, plasma uses gas. LED using diodes, TFT using transistors. So these are different technologies of monitors. These are, you can see CRT, TFT, LED. Right? These are different type of monitors that you can see. Okay, CRT is obsolete. It's all. LCD, TFT, LED, plasma. Out of that, LCD is much popular because it is low cost. But LED is much qualitier. It has more brightness. TFT too. But LCD is more popular due to the cost. Cost is very low. It has a liquid. So similar kind of things, but technological differences are there. Similar to the CRT, still you have pixels. Similar to the CRT, still you have pixels in all the technologies. Pixel illumination technology in cathode ray tube is electronic beam, but pixel illumination technique is a liquid crystal here. Here a diode, here a transistor, here a gas plasma. Right? These are different technologies of monitors. Projector. Overhead projector, multimedia projector, and overhead projector I explained. Multimedia projector can be DLP, digital light processing, liquid crystal display, or LED. Which is better? Is it DLP, LCD, or LED? Which has better brightness?
LED.
It is DLP, right? So LCD here, low brightness, right? Similar to that, here also LCD will have low brightness. It is good for the dark environment. This is low brightness and low cost. So therefore, if you buy a LCD monitor, yes, it is good for dark environment. If your room is dark, LCD will be better because you are saving cost. But if your room is light, so DLP, digital light processing technology, DLP, digital light processing will give you a better brightness. LED has average brightness, right? Here also LED has average brightness. So CRT has more brightness, but LED also bright, but having average. A considerable brightness is there in LED also. For outdoor boards, the low cost solution is LED. Outdoor boards that are there on a local wall board, LED, because again, it is LCD low cost to use karana ba. LED demo light takamadi. LCD low cost tama use karana ba. LED demo brightness takamadi. LED awulak ne. LED LED use karana buluan. That brightness is enough to use in and therefore it is used in large boards. Large wall boards, LED board, bus boards. I think you have seen these LED boards. It's everywhere now. So it is everywhere now. You can see LED signboard, LED signboards, LED boards. You can see here these LED boards. Right. So next thing in the book is printers. This is also very important topic. That is output device printer. Actually, in input devices, we have not much to learn in this chapter, but in the output device, we need to explore more. Stream, projector, printer. There are two types of printers, impact and the second category is non-impact. So what's the basic difference? Impact, non-impact. What's the basic difference? Impact, non-impact printers.
Impact is like typewriter or something.
Impact is
A typewriter.
impact is type. Yes, typewriter is in it's having that impact effect. Impact is basically basically it has, so you can say impact has what's the best? Impact is basically printer head. You can see printer head is touching the paper. Printer head is touching the paper. Impact printers. So let's write down. Printer head is touching the paper. Impact එකක් තියෙනවා, බලපෑමක් තියෙනවා, සංඝට්ටන කියලා කියනවා. It's touching the paper. Yes, typewriter is example. Typewriter is not a printer, no. So typewriter is a different device. But similar to that, you can say ribbon printer, line printer. Earlier there was something called AC wheel, ribbon printer, line printer, AC wheel. Then dot matrix. These are impact printers. Non-impact means jet type. It's spraying the ink without touching the paper. It spraying the ink without touching the paper. Bubble jet, laser jet, or laser printers, inkjet. So these are jet type. So it's going and hitting the paper. So without the printer head is not touching, but ink is straight. Ink is straight. Okay. Please write down this. Ribbon printer, line printer, AC wheel, dot matrix. Okay, finish. Right. So ribbon printer, line printer, daisy wheel, dot matrix, similar technology. It's like your typewriter. It's like the typewriter. So you know the, I think you know the way that typewriter works. Typewriter, basically it has different heads for each letter. You can see this, each letter is connected to this head. So what will happen, this head will go and touch against the ribbon. You can see this black and red one is the ribbon. This will go and touch the ribbon will go and touch the paper. The ribbon will go and touch the paper. Actually, what will happen when you type, when the ribbon go and type the paper, what will happen? It will, yes, it will print. It will like, so it's like the carbon papers. Okay, when the ribbon is going, the like color ribbon, when it go and touch the paper, it will emboss, or it will make that letter appearing. It will emboss the letter. So actually dot matrix uses same thing. Daisy wheel also same. Daisy wheel printer is also same. In daisy wheel printer, you can see it's a wheel, right? It's a wheel. Similar to the typewriter, is a wheel. Actually, not having multiple heads. It has only one head. So one head, but this wheel is rotating. Darage head godak tiyenawane. Mege head ekයි. E head එක ගිහිල්ලා හැප්පෙනවා. මේ daisy wheel එකේ තියෙන head එක. Daisy wheels you can change. So it will go and hit the paper. So doing the same thing, same concept. Same thing, same concept. But the rotation need to be happen to select the correct letter. Daisy wheel. Then ribbon printer. Ribbon printer is again the same thing. So this is actually, this is not the ribbon printer, what I mean, right? So this all ribbon print actually. This ribbon printer is basically printing the ribbons. Ribbon printer. So think about all ribbon printers, line printers and all. Anyway, dot matrix, let's say dot matrix printer. What will happen in the dot matrix head? So you can see this is the dot matrix head. It has 7 pin, 9 pin, 18 pin, 24 pin. These pins will come out. These pins. So let's say you are typing this pin, then what will happen? First 4 pins will come out. The next pin will remain inside, and next 2 pins will come out. First 4 pins will come out. Okay, that 4 pins will print this part. Next pin remain as it is. The next 2 pin will also come out. And when it touch the ribbon, so this pattern will be printed. Right, if all the pins came out, then it looks like I. All the pins came out, then it looks like I. So I think you got the idea, understanding how dot matrix is. So anyway, these printers will make some noise. Right, these printers are noisy. Why? Right, printer head is touching the paper, so you can hear the sound. So that's it. It's noisy, and you cannot do, not good for graphic printing. You can print some graphic, but still it is not good for printing graphics. Graphic print කරන්න බැරි නැහැ, පුළුවන්. හැබැයි එච්චර හොඳ නැහැ graphic print කරන්න. Non-impact are jet type printers. So it is spraying the print, ink ejecting, spraying the ink. So bubble jet and laser jet actually send in wet ink. So bubble jet is also send wet ink. Therefore, it might look blurry, or if you touch the printout immediately, it might get blurred. And when you put water, there is a higher tendency to damage the print. මේ print මේ print out එකට වතුර වැටුනොත් දිය වෙන්න පුළුවන්. ඒ වගේම not only that, if it is not sealed, and another thing is the printout will look wet, little wet. But laser jet, it use ink dust. There's something called toner. Toner uses ink dust. Photo printers all are actually coming under this category. Photo printer is either inkjet or bubble jet. And there's something called dye sublimation printer. So these are the printer categories. Okay, we need to understand this bubble jet, this like bubble jet head or inkjet. So there is nothing specially to analyze about this inkjet head. It is just spraying the ink. You can see this, just spraying the ink using this. So it has this RGB, sorry, not RGB, it has CMYK. Printers are using typically CMYK colors: cyan, magenta, yellow, and key for black. Right, that is also additional thing. This is not coming under the first lesson. Normally screen users, normally, right? So I'll put special asterisk and write for the third point. Normally screens use RGB colors: red, green, blue. Normally printers use CMYK colors. Actually, these colors are chemistry colors. CMYK colors are chemicals. Cyan, magenta, yellow, and key for black. These are chemistry. These are physics. Light. Light comes in physics. Chemistry comes in chemicals. When you mix the chemicals, for an example, when you mix red light with green light, red and green will create the yellow light. Red light with green light will create yellow light. And green with blue light, green and blue will create cyan light. Red and blue will create magenta light. No light present, then it is black. If all light present, that is white. Right? All light present, that is white. Actually, so there is something called Cmyk and Rgb cycle. You can see that in the internet. That is easy way to remember. This is not related to this lesson, but still you need to know, because we are going to learn that in HTML. We are going to learn that in graphics. So there is a color wheel. So you can understand how colors formed according to this color wheel. So this is chemistry colors. When chemicals are mixed, these colors can be formed: CMY, cyan, magenta, yellow, and key. So without black also, black can be created, but it consumes a lot of ink. Therefore, there's a separate black ink. වෙනම black ink එකක් තියෙන්නේ. මේ ඔක්කොම දාලා කළු හදා ගන්න පුළුවන්. හැබැයි ඒකට තින්ත ගොඩාක් යනවනේ. එහෙනම් black ink එකක් වෙනම එනවා. CMY and K. And here RGB, it's lights, right? When RGB create lights, red, green, blue. Red and green create yellow, red and blue creates magenta, and blue and green create cyan. Right? This is RGB. There are RGB printers too. There are RGB printers too. RGB printers is නැත්තේ නැති යනවා. But normally, here you can say this is additive physics, light. This is subtractive paint. Additive means when adding this, it will form the new one. Subtractive means when you subtract the color, it will create this. This is painting. This is chemicals. This is physics, light. So you need to know that when related to this RGB Cmyk related to the printers. Out of this, I'll teach you the laser jet technology, because inkjet bubble jet, there's nothing to learn much. Actually, there are things to learn, but the thing is, inkjet bubble jet, we cannot see that properly in the printer, but there's a technology behind. Other things also have technology, but clear technology is behind the laser jet laser printer. So this laser printers, you have the different. You can ask how laser printer works. Then you can see the structure, right? You can see there's a laser bulb and the toner, which has the toner, and the drum is basically rotating. This toner will issue the color, and there's a laser bulb. But what will happen when you emit the paper, right? When you use the paper, what will happen? The paper will be ionized, or paper will be, so you know, when you touch pen against your skin, that is called static voltage, right? That is called static voltage. Similar to that, what will happen? The static voltage will be given to the paper, right? The static, this, because of the laser unit, so this it creates kind of a static voltage, and so then that static voltage will be given to the paper, and this ink dust will be attached to the paper. Ink dust will be attached to the paper. When ink dust attached to the paper, what will happen? It will iron the paper. It will heat the paper. When paper is heated, right, what will happen? The image, that ink dust will be attached to the paper. When it is heated, it will be attached to the paper. You can see the simple image. So you can see this, because of the this is called charge corona. So because of the charge corona, what will happen? So the paper will be static voltage will be there, static voltage will be there, and according to that, the ink dust will be attached. Then after ironing, it will be sealed into the paper. That is how image is generated using the laser jet printer. Right, that is the technology behind it. Okay, so now you have idea about these output devices and input devices. So we have a few to discuss under this lesson. I said that, but these topics will not take much time. I can quickly cover this within 1 hour. I can cover this stuff. So the remaining things, but it will take some time because I have to explain these technology and all. So then the next day we'll discuss about these optical technologies, and then the magnetic technology and optical technology of storage. One human machine we have already discussed. What we have to discuss is the parts, the components, and the memory hierarchy. I'll do that next day. Okay.
Okay, thank you, sir.
Welcome. Right. I'll send the to you, right?
Okay, sir.